Learning target 6.3 is about dividing polynomials using two methods, long division and synthetic division. We've already talked about long division back in Unit 3, Standard 5. So if you need additional support with this one, check out Unit 3, Standard 5 videos. I am going to go over it quickly, but I already gave the solution. So if you need more support, take a look at those videos. Unit 3, Standard 5. Okay, what I really want to go over is the new topic, which is synthetic division. Now, we're going to be using synthetic division a lot in standard or Unit 6, so it's really important that we have a really good foundation of what synthetic division is. So, taking a look at this, it's a shorthand method to dividing polynomials. What you want to do first is you want to make sure it's in standard form. And it is. It goes. The exponents go from greatest to least. Also, you want to make sure that you're including every variable. So you want to include the zero coefficients if we're missing anything. So if I were going to miss like an x in there, I would put a 0. We're not missing anything. So what I'm going to do is I'm going to list my coefficients. 6, -5, and a -6. Then we're going to create a left-hand box right here, left-hand corner, and I'm going to put my value of a with my divisor. But now the divisor has to be in the form of x minus a. Since it's an x plus 3, I'm always going to do the opposite of what that is. So the opposite of that is a -3. So a is technically a -3. So I put that in that left-hand corner. Okay, so now I'm going to start the process of synthetic division. What you do, you always drop down your first term, 6, and then you multiply your diagonals. -3 times 6 is a -18, and then you add your columns. We get a -23. Multiply your diagonals. We get a positive 69. Add your columns. We get a positive 63. So what we just figured out, this is going to be our coefficients in our solution. Your last term is always your remainder. No matter what, the last term is always the remainder. Then, as we go to the left, this is always going to be your constant, and it builds up. And then it's going to be your x value. If we had more, it would be x squared, x cubed. So those are going to be your leading coefficients in the answer. So we get our solution to be 6x minus 23 plus 63 over our original divisor, x plus 3. All right, I want to quickly go over long division. Again, if you need more support, take a look at the videos, Unit 3, Standard 5. But we have this long division problem. Now, we can't use this problem using synthetic division because of that leading coefficient of a 3, 3x plus 1. So because of that, I'm not able to do synthetic division, so I have to use long division. That's why we need to go over it again. You list your first trinomial under the divisor. We get 15x squared plus 8x minus 12 divided by 3x plus 1. First step, you say what times 3x will give us 15x squared? Well, that's a 5x. Then you take that 5x and you multiply it by both terms here. It's like you do the distributive property. We get 15x squared, 5x times 1 is 5x. Then we take that quantity and we subtract the entire thing. 15x squared minus 15x squared is 0. They cancel. 8x minus 5x gives us 3x right here. Then we drop down our next term, minus 12, and we start the process over again. What times 3x will give us 3x? Well, that's 1. So we write that up here. Then we multiply 1 by both terms over here. 1 times 3x is 3x. 1 times 1 is 1. Take that quantity and subtract it. 3x minus 3x cancels. Negative 12 minus 1 will end up being a negative 13. Okay? There's nothing to bring down, so because of that, that's going to be my remainder, and we rewrite it up top. We go as our solution, and we put negative 13, and we divide it by our 3x plus 1, what were our original divisor. So then my solution is 5x plus 1 plus a negative 13 over 3x plus 1. If you wanted to change this to be a subtraction sign, you could. So make it minus just a positive 13 over 3x plus 1. You could also do that. Okay, I want to quickly go over synthetic substitution. This method is, think of it like you're evaluating the polynomial. So let's say we had this polynomial here, 3x to the third minus 9x squared plus 4x minus 20. And we wanted to evaluate when it equals 2. Well, we would take that 2 value and we would plug it in every time we saw a 2. And then do order of operations, simplify, evaluate your solution, and get your solution. So that was what we've learned before. Well, now let's use synthetic substitution to help us find the answer. What you do with synthetic substitution is you do synthetic division. Your answer is the remainder. So I'm going to put, I want to evaluate when x equals 2. So I'm going to put 2 in the left-hand corner. Now I think a common misconception is as students always want to put the opposite of 2 in there, put a negative 2, but because we're doing synthetic substitution, we actually want to solve it when it equals 2. So we go 3, negative 9, 4, and negative 20. It's in standard form. We aren't missing any coefficients, so we're good. Always drop down your first term, 3. Multiply your diagonals, we get 6. Add your columns, we get a negative 3. Multiply your diagonals, we get a negative 6. Add your columns. Multiply your diagonals. Add your columns, we get a negative 24. What that means is that my remainder is a negative 24, so that means that's my solution. At f of 2, my solution is a negative 24. And you can always check your work by plugging in 2 back into your equation and see if it equals a negative 24. All right, let's do the same thing, but now when x equals a negative 4, same process. Put that in the left-hand corner, write your coefficients, and then do the process of synthetic division. Multiply, add your columns. We get a negative 21. Multiply, you get 84. Add your columns. 88 times negative 4 is a negative 352. Add your columns. We get a negative 372. So what that means is when I solve f of negative 4, when I plug in negative 4 to my polynomial, I'm going to get a negative 372. So just another method of evaluating polynomials when you're given a value.